So hi developers, I am Stone. Today we are going to learn some insights of Spark, like what is Spark, why Spark came since Hadoop was there. So what are the components of Spark that holds, etc. So in this video we will briefly talk about Spark. In our later videos we will be developing Spark application. Okay. So to tell about why Spark came and why Spark, so let's open this document. Okay, this I have prepared. So see, as you can see, what is Apache Spark is an unified analytics engine for large scale data processing. So suppose, think like this, you have a 10 GB or 10 GB not. When big data comes to picture, we deal with 20 GB, 30 GB, even if 50, 60 GB of data files. Okay, so when these large number of large GB of data files you have, and you have to perform a group of operation on that data set, and you have a single system, just think how much time it will take. But using Spark we can achieve this with 100x time faster, because Spark divides the whole. Spark takes the inputs, the data set, and divides the whole into smaller number of chunks into clusters. Okay, so this is why it is why it is unified analytics engine for large scale data processing. And second point is, Apache Spark is an open source. You know that whatever software that comes under Apache Foundation, all are open source. Okay, so and it is a distributed processing system used for big data workload. I told you, though, so Spark divide the whole data set and shuffle it before. Okay, I will tell you one thing. So what happens whenever a data set comes, Spark shuffle the data and divide into chunks and sends them to cluster. So this is what it is saying, that it is a distributed processing system. Okay, it utilizes in-memory caching and optimized query execution for fast queries against of size. Simply put, Spark is a fast and general engine for large scale data processing. In this point, it is mentioned that it utilizes in-memory caching. Before Spark, Hadoop was there. Okay, so Hadoop generally use disk for write operation, for its intermediate operation. That is the reason Hadoop is slow. Okay, and Spark has a concept of RDD. We will be going deeper more and more in the further videos. For now, you just remember Spark has a concept of RDD, resilient data sets. Okay, it uses this RDD to hold the intermediate data in memory and stores in the disk whenever it is necessary. Okay, and the third point is, the fast part means that is faster than previous approach to work with big data like classical MapReduce. We will talk about MapReduce in some time. Okay, the secret for being faster than Spark runs on memory, RAM. I told you, na, Spark, whatever data set you give to Spark it will load into the RAM, and it will process in the RAM, and it will use the RDD for the intermediate operation to hold the data in memory, and whenever it is necessary it will store the data. It will write the data to the disk. Okay, so the second question came to my mind, why Spark came since Hadoop was there. First thing is speed. Okay, Spark claims that it is 100x faster in memory and 10x faster in disk than Hadoop. Okay, and the second point is, Apache Spark achieves high performance for both batch and streaming data using a state-of-art DAG scheduler, a query optimizer, and a physical execution engine. So here they have mentioned a term, DAG scheduler. So DAG is nothing, it is a direct acyclic graph. It is nothing but a graph which holds and track operation applied on the RDD on the data frame. Suppose you have a RDD or a data frame. You are doing some group of operation, like you are doing a group by, then you are doing a doing a group by average function. After that you are doing a union or something else. So it will track the operation of all the it will track all the operation that are applied on the RDD and the data frame. So here you can see the image. This is a logistic regression problem that processed in Hadoop and that processed in Spark simultaneously. You can see the amount of time taken by Hadoop and the amount of time taken by Spark. Okay, so it is far more far more high. Okay, so that's why Spark claims that it is 100x faster than Hadoop in memory. Okay, by looking this image you can guess how really Spark is faster. Okay, for those who are not understanding the image, because in the image it is shown logistic regression, but it is a mathematical term. What it is doing here? Okay, basically we build ML models using algorithms like regression, classifications, and etc. Okay, so that's so linear regression is also a example of regression model. Okay, so we have different type of regression model like linear regression, logistic regression, lasso regression, polynomial regression in our machine learning. Okay, so but we will be going deeper and deeper more whenever we will start our Spark ML leap. For now just focus on the diagram. Okay, so we can build an ML model using linear regression. In maths, you must have learned linear regression nothing but a predictor variable and a dependent variable which are dependent to each other in a linear fashion. Means there will be two variables which will be dependent to each other in a linear fashion. Okay, don't worry guys, we will be learning all those when we will start Spark ML. For now we will focus on Spark. What are the insights of Spark that Spark holds. Okay, and the second point comes to that Spark provide that ease of use. Okay, so write application quickly in Java, Scala, Python, R and SQL. So you can see large number of programming language it is supported. Okay, second part is Spark offers 80 high level operators that make it easy to build parallel apps, and you can use it interactively from the Scala, Python, R and SQL cells. So cells is nothing like it is just like an CMD like cells, where we can if you have Spark installed in your system, you can go to the CMD and write Spark cell. It will start the Spark application, and you can create data frame, and you can perform operation on the data frame. Okay, so one interesting fact is you can write Spark application in Java, Scala, Python, R and SQL. Okay, and for your knowledge, Spark is written in Scala and Scala runs on JVM. Wow, it is interesting. Okay, and Java also runs on JVM. Okay, one interesting fact you should know that when we use Python for Spark development, basically that is called PySpark. When we use Scala with Spark, that is Scala Spark, but when we use Python with Spark, that is called PySpark. So whenever we are using Python to develop Spark application, internally all the Python code will be converted to Scala and it will execute the operation. Okay, and the third point comes that generality. Okay, it combines SQL streaming and complex analysis. Spark powers a stack of libraries including SQL and data frame, MLlib for machine learning, GraphX and Spark streaming. You can combine these libraries seamlessly in the same application. You can see the diagram here. Spark SQL is there. So for the developers who are coming from SQL background, they don't need to learn a functional programming like Scala, or they don't need to learn programming language like Python, etc. Okay, they directly Spark also supports Spark SQL, where we can write Spark general SQL queries. Okay, instead of functional programming, we can use general SQL queries to whatever operation that you want. You can do it also SQL queries also. Second part Spark hub is Spark streaming, and third part is MLlib. It supports machine learning. It is a library for machine learning operation. Okay, fourth one is GraphX. Okay, so in this part you might be thinking, where is Spark core? We are talking about lot about Spark core, but where is Spark core? So this is what Spark core. All these four libraries are built on the top of Spark core. Okay, so don't worry guys, we will cover all one by one. We will start with the Spark core, but I guarantee that we will cover all those four libraries, all the four components with the Spark core. But from tomorrow we will be focusing on more on Spark core, because it is the foundation. If the foundation is strong, then we can move forward very seamlessly. Okay, And the fourth point is run everywhere. Spark runs on Hadoop, Apache Mesos, Kubernetes, standalone or in the cloud. It can access diverse data sources also. Diverse data sources means you can pull data from Azure Blob Storage, you can pull data from HDFS, you can, if you have some other data lakes also, you can pull data from that also. You can run Spark using the standalone cluster mode on EC2 mode or Hadoop, Yarn or Mesos or Kubernetes. So Yarn or Meso, these are the cluster manager that management that Spark uses to run. Okay, so access data in HDFS. I told you, if you have any type of data lakes, you can use it with Spark. Okay, there is no issues on it. Apache Cassandra, Apache HBase, Apache Hive, hundreds of data sources. It supports it supports hundred of data sources. Okay, so as you see, Apache Spark, Hadoop, Cassandra, all it supports. So I told you before Spark, MapReduce is there. What is MapReduce? MapReduce is a heart of the Hadoop. Okay, before Spark comes into picture, Hadoop was doing a great job. So MapReduce is a programming paradigm that enable massive scalability across hundreds or thousands of servers in a Hadoop cluster. Okay, MapReduce is known as the heart of the Apache Hadoop. I told you it is the because totally Hadoop concept is about MapReduce. Okay, from the name we clearly assume that MapReduce is two separate and distinct tasks that Hadoop program performs. Okay, the first job is map job, which take a set of data and convert it to another set of data, where individual elements are broken down into tuples. Tuples means key value pair. If you have familiar with Python, then you may have heard about tuples. Okay, so what map job do, it takes a input a set of data and convert into another set of data where individual elements are broken down into tuples. Okay, then the reduce job comes into picture. Okay, reduce job takes the output from the map as input and convert those tuples into smaller set of tuples. Again it will reduce it. Okay, so reduce job is always performed after the map job. One thing you have noticed that I have told many times, Spark claims that Spark is 100x faster than Hadoop. Okay, why MapReduce is slow and Spark is faster? This question comes into mind. Okay, so I'll tell you, Spark claims that Spark is 100x faster than MapReduce on memory and 10x faster than disk. Okay, this is because does the process in the main memory of the worker node. I will tell about what is worker node and what is slabs. I will tell whenever I will start teaching you Spark core. I will teach you more about worker node, what is slab, all those things. Okay. So why MapReduce is slow and Spark is faster? This question comes into my mind. Spark claims that Spark is 100x faster than MapReduce on memory and 10x is faster on disk. Spark claims this is because it does process in the main memory of the worker node and prevents unnecessary IO operation with the disk. So I told you, it has a concept of RDD that holds the data in the memory for during an intermediate operation, and writes the data whenever it is necessary. It doesn't write the data after each operation to the disk like MapReduce do. Okay, that's the reason MapReduce is slow. Okay, I will explain it more clearly on the upcoming videos when I will start Spark core. I will teach you what is Spark, what is worker node, what is slab, how datas are shuffled and divided and sent to cluster. All those things I will tell about. Don't worry, guys. Okay, so there is a concept of resilient data set. I told you RDD, which Spark uses to store the data in memory and write it to disk when necessary. But on the other hand, MapReduce, after MapReduce job, the data is shuffled and written to disk. So this is the reason latency is high in MapReduce and latency is low in Spark. So this is the reason Spark is faster and MapReduce is slower. So this is all for today. I am keeping the video short so that you will also feel interesting to learn. In this video we have learned what is Spark and why Spark came into picture since Hadoop is there, and what is the use of Spark and how we use Spark. So all of this, I hope you guys like these videos. Just please comment, subscribe and share with your friends. Thank you.